Welcome back. Thanks so much for joining us. We've got the absolute pleasure of Mr. Luca here from TrueLayer. He's going to run us through a little bit about the life of a tech lead at TrueLayer. He's going to talk to us a little bit about open banking and building some of their mission critical services in Rust, which I love. I can't wait to see. I've been doing some research myself, so it'd be really interesting to see what you guys are doing. So, Luca, do you want to just give us a quick intro into you, maybe a little bit about your journey with TrueLayer? Just give us some info about yourself and TrueLayer.
Absolutely, and thanks first and foremost, Elliot, for having me. So, what to say about me? Been in the industry for 3 years, more or less, give it or take. I joined straight out of academia as a machine learning engineer, data scientist. Been doing that for some time. I joined TrueLayer as a machine learning engineer almost 2 years ago at this point. And then I pivoted for a variety of reasons into more backend engineering. And so I started to do a little bit backend engineering, became the tech lead of our data product, eventually led the connectivity function, was in charge of integrating against the different providers in Europe. And now I'm starting a new product line, and that's where the Rust story kind of unfolds. TrueLayer itself has been a startup for 3 years or so. I joined almost 2 years ago when we were 20-something. Now it's 130 strong, I think, last time I checked. So it's been quite a journey.
Nice.
It's quite nice. It's quite impressive, actually, if I think about it.
Yeah.
TrueLayer is in the business of financial technology. So we like to define ourselves a little bit as a financial technology platform. So what we do is we offer services, mostly via API, so programmatic interface, for people to integrate certain types of financial technology capabilities into whatever they're building. At this point in time, we're mostly focusing on access to banking data and initiation of banking payments. That are the two main things we focus on as capabilities that we provide.
Yeah. You've probably given us a definition in there somewhere around connectivity, open APIs, but what is open banking? Can you help some of the audience understand what open banking is? This doesn't have to be textbook answer. This can even be your version, but what is open banking?
Well, the textbook answer would probably be too difficult for myself included, so I'll give you my version of it and my spin. Well, open banking is, in the strict sense, an initiative that was started in the UK a couple of years ago, where basically regulators said to the major 9 banks, you need to provide access to banking data and payment initiation on banking rails via API. You're mandated to do so by this date, and you're mandated to do so agreeing with this specification. And when that happens, of course, people start to build on top of these APIs. And then even banks who are not mandated by regulation to do so, they start providing the same APIs because they want their customers to be part of that ecosystem. Then at the same time, you have in Europe what we call PSD2, so Payment Service Directive number 2, which follows more or less the same schema of open banking. So it mandates all banks across Europe to once again give access to banking data and payment initiation. There are some differences between open banking in the UK and in Ireland and PSD2 in Europe, but at a high level, that's what we're talking about, is getting out of that lock-in of saying the only kind of entity that can access my banking data is the bank, to a world in which you can say, I want to be able to decide who has access to this banking data, and potentially also if I want to get them out of the bank itself.
Okay. So from my understanding, there's quite a lot of players in the open banking space at the moment. Okay, that seem as if they're growing and thriving. Why are TrueLayer a little bit different from some of their competitors? What do you guys do really well?
Well, there's various ways in which you can kind of slice and dice the magical quadrant of open banking. So you can go for companies who are specialized in serving certain specific verticals. You can go for companies that are specialized in certain geographies. What we try to do at TrueLayer, we try to be the underlying infrastructure. So that's what we aim to do. So what we aim to do is to provide a service which has the largest possible coverage. So we aim to connect all Europe and beyond over the next year or so. We aim to provide reliable infrastructure, so something you can depend on. And we aim to be able to serve customers with all kind of expectations. So from the smallest startup who is in incubator today to the largest corporate or challenger bank who has thousands of customers and needs to operate at scale. So we see ourselves mostly as an infrastructure provider, which kind of directs a lot of the choices you make from a product perspective. So very often we provide white label product because we're not a consumer brand. And we very often don't store any data that are passing through our system if you just want to use it as a connection rails. So there's a lot of things that made us an ideal partner for certain types of companies that generally want to work with us.
Okay. From my understanding and doing some research, you guys have got a couple of APIs. You touched on one, data API, yes. Payments API. Okay.
Yes.
So it would be really good to understand, or going into a little bit more detail from just what you've discussed in regards to being essentially an infrastructure provider. Can you go into a little bit more detail as to what some of those APIs can actually do for customers, or what that actually looks like?
Absolutely. So that API, as the name kind of implies, gives you the possibility of accessing your banking data. So when we say banking data, what we generally mean is your list of current accounts and credit cards with a certain bank institution. And for each of those current accounts and credit cards, your balances, your history of transactions up to a certain point in time, potentially your standing orders, your direct debits, and so on and so forth. So everything that kind of forms that current account. Payments API, on the other side, is kind of the right access into the banking infrastructure. So data, you read only, you can't perform any action, you can just get some information. Payments API allows you to do payment initiation. So you can authorize a single payment through your bank, which means that it's a bank transfer, which means that goes through all the authentication, authorizations, and checks of any normal operation you do in online banking. So you generally have strong customer authentication, potentially biometrics, second factor, whatever you set on your banking account, that's when you're going to be finding that. And you can see them being used by different companies might use one product, not the other. Some companies might use both. I don't know, if I want to make an example of a very typical use case, you can pick Revolut, which is one of our biggest customers in the UK.
Yeah.
So if you go in the Revolut app, you can connect your bank accounts in order to see all your accounts in a single application, so alongside your Revolut Nova wallets. But you can also top up from your bank account to your Revolut directly inside the application. That top up works with our Payments API, and then Revolut can also check that the payment settled in the other account via the data API if they want to. And you can also see yourself that the payment moved because it's in the list of transactions of that account. So the two products have a lot of synergy, and depending on the use case, they're generally used in conjunction.
They do have a lot of synergy. That's a really good description. I can actually paint a picture now of how the product might actually look for a user. Well, where does it get really complex for you and your team? That's a question that I've probably put you on the spot a little bit there. Where does it get complex for you guys? Do you typically find in the office, or complex and fun?
Well, complex. It's always fun in a way. Some things are more hard fun than others. I would say it gets really complex. First of all, from a point of view of scale, people often underestimate just how many banks there are across Europe, which means you need to build a high number of integrations. Now, Openbanking mandated the banks to provide this information programmatically, but it also mandated a specification. So all the UK banks were required to implement according to the spec. Now, some did it better than others. I'm not going to name names, but overall, you could say, well, there is one API, and then there are like slight customizations that you need to make all the banks work. Mm-hmm. this is not what happened in Europe. Europe, the regulators simply said, you need to have these capabilities. Tell us you have an API, we'll check it, and we'll tell you if it's compliant or not.
Uh-oh.
Now, some specification did arise, because banks, of course, got together and talked to each other and said, well, it would be nice if we kind of offer one API instead of 250,000 different versions. But, of course, it's a little bit spottier. Some banks have their own custom implementations. The specifications are a little bit looser than Openbanking, so there's a lot more optionality on how you can do certain things. So that definitely is a challenge. Now, the big challenge is testing. So most banking APIs either don't provide a sandbox or provide a sandbox environment, which generally behaves quite different from production. So it's very difficult to say, well, it works on sandbox, it's going to work in the production environment. That's generally not the case. And in the production environment, furthermore, you generally need a real bank account to test. And that's very complicated at scale, where you need to test hundreds of banks. Plus, very often you have edge cases that only verify under specific conditions. So if you open this bank account in these years, which was in this product line and now doesn't exist anymore, then this weird thing will happen with your balance. And those are like the kind of things you only find when you launch. Okay. So in one way it's good because we are pressured to like get these things out early, even if maybe they're not the top quality we want them to be, because we know that simply there are unknown unknowns that we'll never know until we scale. But of course, that's a little bit challenging. And the other piece is, of course, that in the end, doesn't matter how elastic our platform is, very often the bottleneck in terms of throughput goes on the bank side. So we also need to be a little bit smart on how we limit traffic and do back pressure to kind of protect the banking APIs, sometimes some spikes of traffic or other things that we might handle, but they might not be. Okay. They might not consider fair usage. Let's put it like this.
Yeah. Okay. Yeah, I can imagine. Now you say it. This may not be the right terminology, but the localization for the banks, not necessarily in terms of language, but actually understanding what the banks need to be able to integrate with them, is probably really tough for you guys. So, well done.
Oh yeah. Well, documentation is also not in English, and
that's true. Which obviously plays the localization part. We like this question on here, and I'm not sure if you're allowed to divulge some of this information, but what sort of scale or intensity might you see the TrueLayer platform undergo at peak times?
Well, can't say numbers, as you might imagine. Yeah. I say that we run elastic infrastructure, so we scale to several tens of instances very often to kind of handle the load on the main product when we are under load. I think it's grown massively. That I would say, like you say before, what was fun, I think that was very fun. Like as I said, I started when we were 20.
Yeah.
And I think the numbers we consider to be high 2 years ago are very different from the numbers we consider to be high today. And going through like multiple iterations of scaling the product, 10x the order of traffic, is definitely a very fun challenge as a backend engineer.
That's quite cool.
It's going to be more going forward.
I love that. I love that you've been there since the early days. You've seen it evolve. You've been part of the journey. How has the culture and the technology, which will get us onto our next couple of points when we talk a little bit about Rust, which I'm really excited about, how has the technology and culture changed from being employee 20 to now 130 employees?
Well, in one way, I think it's too early to say because you generally rationalize how the culture has changed a certain amount of time afterwards it has actually happened. So I can probably tell you how it has changed from going to 20 to 70. That's the last stage I fully digested. But a lot of things change. Like when you are at a stage where you have like 10, 12, 13 engineers, not only you know everyone, which is, of course, a big plus, you also know exactly what everyone is doing. Like you have a perfect understanding of what every single engineer in the company is working on. You know how everything is architected, you know, the failure modes and most of the things. Like knowledge just circulates around the company and there's no really silo, just limit of understanding of how stuff works. Now, when you scale to something like 30, 40, 50 engineers, and you start to have tens of microservices, and you start to have multiple products with their own failure modes, the situation changes quite dramatically. First of all, not everybody is able anymore to kind of jump on a code base and puts their hands there. But also, not everybody is able to troubleshoot an incident. Like, not everybody can jump and say, oh, yes, this is failing because that particular service has these issues at scale, and we know that it's going to behave that way. You need a lot more structure around being able to kind of rationalize technology choices, patterns, document what you're doing, which I mean is a very good thing to do from the beginning. But as it often happens, you don't do certain things until you need them, and generally it's too late. So you're just going to need to go there and say, okay, well, now we need to be a little bit more deliberate. And that also comes not necessarily by the number of people which are part of the engineering organization. It also comes from the change in the type of customers you have. So when you're at the very beginning, you generally have as customers the very early adopters, like the people who are at the cutting edge of the field, who are willing to play with a service that might be not as reliable or battle tested as other services, because they want that capability, because they believe it's a differentiator. So they're willing to pay the support and maintenance cost of integrating against you, even if that might not be ideal at the point in time. Now, when you start to scale and you start to get bigger and bigger customers, and some of them are what we would define enterprise. Yeah. So customers who definitely don't want spend their days chatting with you about your problems. They pay for your service, they want it to work. Then you need to get a little bit more discipline. So if there was a little cowboy deployments in the early days, then that definitely changed as we went forward. There's more emphasis on testing. There's in general, I think, more emphasis on being battle production ready in many, many ways that we might have maybe compromised a little bit on at the very beginning.
Yeah, I love that. And I see that being quite a common theme. I think quite a lot of companies need that consistency framework. It's a really hard framework to find, but a consistency framework with good testing, good documentation, and building on that, I think it's a really important foundation, or from what I hear, it's a really important foundation. You embed that into the culture, you're able to build from that. You mentioned that's one of your challenges, integrating with some of the enterprise banks, which I can imagine. Have you got any other examples? I know we've spoken about sometimes the localization, obviously the support mechanism. Any other challenges that you find integrating with some of the big banks?
Sometimes the feedback loop can be fairly slow. So you might hit an issue and you submit a ticket and you get an answer like 2-3 days afterwards.
Yeah.
Or maybe you didn't explain yourself very well, or they didn't understand. And so before you get an answer, like there's a ping pong that might last for days. And so if you are unlucky and on that particular provider, you hit 4 or 5 of this, what you think was going to be an integration that was supposed to like take you 1 week takes you 2 months.
Yeah.
So it's in general very difficult to reason about how long it takes to do a bank. We can get some kind of reasonable estimates in the aggregate. That's how long we think it's going to take to do a country, because these like kind of unknown unknowns balance out when you have many, many banks. But sometimes, yeah, you can eat like very nasty integration that can take you way longer than you were expecting. So estimating is very, very difficult.
What happens if something is mission critical?
Everything is mission critical.
Well, okay, we're going to get to that. True. What if something is or could be really detrimental? Do you guys just send some engineers around to the office and start knocking on the door and say, help?
No, that would be ineffective, especially now that the office is empty. So the way we do it is, since we started to scale, we run a voluntary on-call rotation. Now, voluntary doesn't mean that it's not paid for. It means people just they need to raise their hands to say, I want to be in the on-call rotation. Of course, they're compensated. I was one of the founding engineers of the on-call rotations when we started it. We were a group of 6. And the on-call rotation works fairly simply. So all the services in TrueLayer infrastructure, in TrueLayer production cluster are instrumented with metrics. And on top of those metrics, we run a set of rules that we call alerts. When those rules are not verified for a certain amount of time, maybe 5, 15, 30 minutes, depending on the type of service, the type of failure, and so on and so forth, then those alerts will fire into pages. Then each engineer has configured it however they liked it the most. I have it as phone calls. So when I'm on call, there's a first layer that receives the page. They have 15 minutes to jump on it. If they don't, it escalates to the second layer. And so we run a rota where basically you will be on call for 1 week as a first layer, on call for another week as a second layer, and then you will be off until it's your turn again. It's been good, I would say. We learned a lot. We learned a lot about what are good alerts, what they look like. Yes, that's of course that. You can have noisy alerts.
What is a good alert?
Good alert is one that alerts you when something that the customer can see is failing. Like having a service in your infrastructure cluster could be completely broken. As long as it has no effect on the customer, you shouldn't wake an engineer. Like that's the golden rule. Now, it sounds easier than it actually is to do in practice, because you're like, well, but if this database is hitting this disk limit, most likely it's going to be an effect. So it's always a little bit of a balance game. But like, as a rule of thumb, you want to alert on stuff that is visible. Anything else can be a warning. So it goes on another kind of notification channel, and people can pick up in the morning.
Yeah,
they don't need to be woken up during the night or during weekends to go and look at that specific thing.
Okay. And touching on a couple of points, we've used this phraseology, and we're going to talk about it in the next couple of moments with the Rust piece. We've spoken about this in some of the Engineers Podcast previously. How do you guys set yourselves up to be mission critical and performant? That something from our audience they may be able to take away and think, oh, that's a really good idea. I haven't thought about doing things that way before. Probably you've got a load of context in your head, but if you can think about maybe some of those principles that you've just mentioned that some of your rota team follow, there's other things that you ensure that you are mission critical and performant. What would you say speaks of really good value for you guys at TrueLayer?
Okay, I'll do how to phrase this. I would say that the number one thing which I've seen teams doing, which generally correlates with them operating a very stable, very reliable service, is engineers being first and foremost operators of what they run. So at TrueLayer, we have you run it, you build it, you run it type of setup, which basically means we don't have QA engineers. So we run testing entirely in the dev team, and the DevOps team is just in charge of the underlying platform. So they operate the Kubernetes clusters, the database setups, this kind of stuff. They don't kind of intervene in any of the production incidents that affect our services. When you have an operator mentality, the type of questions you ask when you merge a PR, when you are developing new functionality, change dramatically. Like when you have an operator mentality, the first thing you kind of ask when you see a pull request is, how will I understand if this thing breaks production? Do I have the right set of probes and metrics and alerts to know if this is going to fail? Do I have enough logs to troubleshoot this issue if tomorrow I receive a ticket about it? All these things compound, because of course you're going to make mistakes. Like nobody is going to operate 100% infallible service that will never have any problem. You're going to have problems. Like the difference is in how ready you are to tackle them when they arise. So how quick you are to restore services. So it's your rollback procedure thought out. Do you know if you can roll back these changes? If not, what are you doing to mitigate the risk? Can you roll this out incrementally? Like I think we've done a couple of times. We recently re-architected most of the platform. So we changed completely the architecture of our data product. And we did it entirely to dark traffic. So we did a dark release and slowly moved traffic one provider at a time.
Okay.
Over the course of something like a month. And some of those changes caused failures, but we were rolling them out to 0.5% of the population of our users. So basically nobody noticed. Like they were basically indistinguishable from the occasional bank throwing a 503. So it was kind of like, it was very good. Like we were surprised with ourselves, considering all the new things we introduced with the re-architecting. It was absolutely uneventful. And that's what we wanted to have. So it's basically around being a very negative person, always thinking about what can go wrong and preparing for that. And like have a synergy with your support team. So making sure they can be effective as well. So they have all the logs, all the instrumentation they need to troubleshoot tickets, and everybody is enabled to do the best job they can.
Yeah, nice. I like that. And we've touched on this in one of the previous podcasts as well. Sometimes it's really tough to know what you don't know. So having that negative, pessimistic outlook on what could go wrong or what might go wrong with this, I guess makes you think down a very different route and think, okay, let's be a little bit more abstract about this and think about some of those areas. Nice. Okay. So what made you think about moving some of those services to Rust? I'm really interested.
Well, as it happens, technologies never happen in a void. They always kind of happen because there's somebody who's passionate about them. In this case, at TrueLayer, that was myself.
Nice.
So I studied Rust, using it for some open source projects almost 2 years ago. Well, a little bit more, almost 3 at this point. It was completely random. Like it was mentioned once by my previous CTO. At the point in time, I was working as a machine learning engineer, and it sounded like a very good fit for doing some native modules in Python. So kind of speed up some workloads that we were doing on the machine learning side. Mm-hmm. Picked it up, read the Rust book, liked it much, studying, contributing to a bunch of open source services, and I kept doing it for up to now at this point. And so when I joined TrueLayer, of course, our main stack was .NET, and we were doing some Python for the machine learning stuff, but I kept playing around with it. And it was originally like the small projects. So you do like that CI script, that is that bash script that everybody's copy pasting, and every time like changing one line so that it's impossible to get CI done without trying 50 times to build. And so you say, well, you know what, let's do a little binary. Let's put all this stuff together. Let's make a little bit of structure. And you do that static Rust binary that's there. And then everybody uses it and it works. And then you do, well, we have this small thing that we need all in the dev cluster to kind of reduce the number of replicas, just because we want to be sure that we're not spending tons of money in a development cluster at night when your body's using it or wasting electricity. So you say, well, let's do this Kubernetes Rust controller. And that's like how you, over time, build up, I think, a little bit of mind share. Now, it's not a streamlined process. I think introducing a new programming language is a huge change. But when you start to capture a little bit imagination and say, well, this language is interesting because it does these things that our current stack doesn't do. And actually, if you put them together, it's a really nice toolkit. Like with this, we can grow and do most of the stuff we want to do, and we probably don't necessarily need to add another programming language down the line. And then you start having those conversations. And after a year, I guess, or even more, then we started to have those conversations. Then here we go. We're starting a new project, which is substantial as a new product line, entirely Rust, which, awesome. As I think about it, is almost very scary, but it's also very, very interesting.
I love the confidence. What strengths does Rust have? You mentioned, you were obviously building out some projects in Rust, and you've obviously started to dive into it a little bit more in your personal time. What strengths do you think the language has and can give TrueLayer?
Okay, for TrueLayer specifically, I think our main focus at this point in time is on correctness and maintainable code. So it's in being able to really write code that express the type of domain constraints and the type of business logic that we're trying to perform, and being able to make it so that it's easy for another developer to go into it and check. Now, I like to say that Rust takes all the things we learned in functional programming languages like Haskell or Camel, that kind of languages, and takes all the pragmatic bits, all the stuff that you use 98% of the time in those languages, and it packages them without using all the names and all like the theory that is behind them, but just gears them for productivity. So you get errors values, you get algebraic types, which allow you to implement constraints very easily. You get exhaustive match, the structuring. You get a lot of those things that make the Rust type system, I think, the strongest type system outside of purely functional languages. Okay. And when you have a very strong type system, that is great if you're doing domain-driven design, if you're doing domain modeling, if you're trying to make sure that certain failure scenarios are always handled, and so on and so forth, because it just changes the way you operate. Like, think, for example, the switch between exceptions and errors values. When you're when you're calling a function in a language that is exception-based, think, for example, Python, you never know if that function is going to throw an exception. And more importantly, you never know what exceptions that function is going to throw, unless it's documented, which is already like at 0% of the code you're using in your libraries. And if documented correctly, so they didn't introduce another exception type afterwards. And third, the other option you have is go and inspect the code. And then you might need to do that recursively because they might call other code and in turn might raise exceptions that they're not catching. So like the third level dependency of your dependency could throw an exception that you need to be aware of if you really want to handle it. Now, that's not the case if you have errors values. You look at a function signature, returns a result. So happy case, I get this. Unhappy case, I get these possible failure scenarios. And I can choose which one I want to handle. I can choose which one I want to ignore, which one go into my catch-all. But I know that that's a done deal. I've handled all the possible failure cases, which if we go back to that mission critical and what could go wrong, that's really powerful. So most and foremost, I would say Rust at TrueLayer is a type system. Time of adoption is we want to write correct code, and we think Rust makes it easier to write correct code in a lot of scenarios. Now, of course, you also have the other angle, which is performance. Now, we don't write super low latency systems, like we're not into the 1 millisecond type of latency constraint. Mm-hmm. So I'm fairly sure that if we wanted to, we could push our .NET Core stack really hard to reach most of the performance goal we have. But Rust gives us a lot of predictability and gives us the possibility to go really far if we want to. So it kind of gives that natural extensions that if tomorrow we need to write some component, which for some reason needs to be really, really stable and really, really predictable, then we have the right tool for the job. So we can go the full spectrum from real expressive high-level language like Python and .NET to a little bit low-level, more mission-critical systems, and you still have something that your engineers can use. Nice. So you don't need to go and write C modules or C++ modules or write consultants to do that. Your toolkit can support the whole range of challenges that you're going to find, nice. Which I think is really cool.
That's smart. I think diversifying the toolkit is really smart, especially what you're doing. And I think the interoperability is, I think I've said that correctly, interoperability of Rust itself looks really good. I've got a couple of questions that I've asked a couple of people offline that I thought would be really interested. How do you handle some of the build times in Rust? Don't sigh.
I do. I mean, that's one of the pain points. I mean, build times, so it depends. Build times can be painful, but depends what you're doing. So when you're building for local development, so when you are actually writing code, what really matters is incremental compilation, because you will do a clean build once, generally when you start a project or you clone the repo or whatever you're doing. Then from that point onwards, it's always incremental compilation. For most cases, cargo check is really fast. So if you really want to get feedback about does this compile, type of question, that's quite speedy. Never was an issue for me.
Cargo check? Is it?
Yes. So checking that it will compile without actually generating the underlying machine code. Okay. So the compiler only does kind of first pass, which is much more lightweight, instead of actually building a binary. The second thing that I generally do is I run a loop. So basically, my general local setup is you observe the file system of a project. Every time something changes, you first run this cargo check step. So you check that everything compiles. If everything compiles, then you run tests. And that kind of feeds really nicely if you're doing test-driven development, because you can get very fast feedback. So you stop writing, you go check, you already have your test results, you go back, say, okay, actually, that was wrong. Smart. So that is fine. Sometimes even the incremental compilation step can be a little bit challenging if you're using crates that do a lot of compile time black magic, like Diesel and other crates who do type level computations. That can take a few seconds, but I generally never found that to be an issue. Mm-hmm. What's really time consuming is when you're doing release builds, especially in continuous integration. Mm-hmm. So where you're building Docker containers or stuff that generally you want to be reproducible, so you generally start without a cache. That can take like 5, 6, 10 minutes sometimes, depending on how complex the project is. So yeah, that is painful. I'll be really honest, that is really painful. There are things you can do to make it easier if you want to compromise a little bit on the isolation level of your build. Another thing you can do, you can be smart around how you build your Docker files. So you can optimize them for Docker layer caching. So as long as you don't change your set of dependencies, most of the layers will be cached. So you save quite a lot. But yeah, release builds, so artifacts that go into production, that's time consuming. All the other CI steps you can really optimize. Published a blog post a while ago, I think it was 2 weeks ago, on what I generally use as a CI setup for REST. Yeah. Testing, linting, security checks, all this kind of stuff with good caching, which most CI providers give you. They're really speedy. Like I can get most of them to complete below a minute, which I think for a CI integration step is fairly reasonable.
Nice. Well, at least you've got a structure to be able to counter it anyway, which I think is solid. What do you think about the borrow checker?
I think it's actually depends what you're doing. It's often a little bit overstated. I think it's very, very cumbersome at the beginning when you are picking up the language, because it's one of those concepts that is actually really new for most people who come to Rust. I mean, it was certainly new for myself. It's like when you move between a Python and a .NET and a Java, like they're not object-oriented languages. Like they might have different idioms of doing certain things, and certain things might be nicer or worse in a language instead of another. But your mental model really translates well. Like the patterns are more or less the same. The syntax and the specific constructs used in the language might be different, but the way you structure your program is the same. That changes quite dramatically in Rust. A lot of things that Rust does very well are enabled by the fact that we have ownership and borrow checking, so that you are guaranteed that only one certain piece of the product at any point in time can have mutable access to something. Or you can have immutable access shared, but then you cannot mutate, and so on and so forth. That sometimes forces you to really restructure the way you're thinking about the problem to make it so that you don't have mutable accesses everywhere. It would be fine in many other languages. I mean, I've seen and done things in Python that my Rust self kind of deprecates deeply, but it's perfectly fine. Different languages have different idiomatic code paths. It becomes tricky, I think, even when you are experienced, when you do asynchronous programming. They got much better with async await. So borrow checking across await points has got really much more ergonomic, but there are still edge cases where you really need a deeper understanding of the ownership model to understand why the compiler is rejecting certain pieces of code. And I think that can be troublesome, especially if you're just jumping on the language. That can really sometimes make you waste tons of times that otherwise, with a good linting from the compiler, a better diagnostic, you could troubleshoot much easier. Good. It's got much better, I must say. Last 3 months, 6 months, the improvement of async await diagnostics from the compiler has been exponential. So I'm quite confident a lot of the rough edges will be smoothed out going forward, but it would be unfair to say that it's not a pain point.
Yeah. We don't have any sort of bias towards any programming language, any companies here at Engineers. We did put out a tweet and say we're really interested in talking to people from, let's just call it niche languages at the moment. But I've heard some really, really good things about the Rust community. Again, we don't have any ties to anyone. We're just interested in talking to people. But I would definitely recommend anyone that's interested in what Luca's saying to go and check out some of the Rust community on Twitter, forums, online, and have a look at some of their content. We're probably obviously going to think about wrapping up in the next couple of moments. I always like asking this question: if you've got any advice for anyone stepping into engineering at the moment, or if you could tell yourself something from 5 years ago, Luca, what would it be? What would you be saying to someone at the moment who's looking to step into engineering?
That's a difficult question. Also because
It's a
I
broad
arrived at
question as
engineering.
well.
Arrived at engineering in a very kind of lateral path. So I'm a mathematician, so kind of a weird entry point into the industry. Like if I think about what I look for in candidates, so where I'm recruiting or where I'm the hiring manager, which I think is probably the most relevant
That's more
type
relevant.
of mindset.
Yeah.
I would say what I look for is people who have done the real thing. Like even if they don't have production experience or they have not worked for a specific company, what I look for is, do they have any project where I can see that they thought it out, where I can see that they tried to build something that worked as a product. Like very often you get university projects, you get like small tools, but you don't fully understand if that person has actually thought it out, or if they can collaborate with other people, or if they can think about trade-offs in what they're doing. And I think very often like a simpler project, but is fully fleshed out, which has a good README, which explains why am I doing this instead of doing that, and I thought about doing this, but actually I wanted to keep this simple. Even better if it was a project that you did with other people, that tells me much more than a lot of like certifications and courses and so on and so forth. In the end, whatever your stack and technology is, most likely it's not going to be exactly what you need on the job. Like every company has its own quirks, its own proprietary tools, and so on and so forth. What I need to understand is, can I trust this person in front of me to learn fast enough to be a productive member and a happy member of the team I'm putting them into?
Yeah, I actually couldn't agree more with what you've just said. I speak to lots of people in the industry, and the decision making, the ownership, and like you said, the trade offs is a really, really, really important piece. I find when talking about your projects, I always say to people, make sure you're articulate, you're concise, and you've got the context of what conversations you've been involved in, what tool set you used, what you could have used for different use cases, and so forth. Because I think that sort of thinking can take you a really long way.
And testing. Put tests in whatever you do, and that's gonna make you shine across like hundreds of submissions. If you are good at writing unit testing and integration testing, that puts you already miles ahead of most of the applicants to any position.
Good. I love that. That's really good feedback as well. What are you guys looking for? Anyone that's listening to this, what are you guys looking for?
In what way?
Sorry,
What do you mean?
yeah, sorry, I was just about to say, what are TrueLayer hiring for? That anyone listening to this could say, I really like the sound of working with Luca on his very brave Rust project. I'm going to go and sit alongside him.
So on the very brave Rust projects, we are currently looking for 2 backend engineers. So either Rust experience or Rust curious. So if you really like the sound of what you're hearing, there's a job on that specific team, which is going to be fun, and you're going to be working with me directly. Otherwise, we are hiring for tons of backend and front-end engineers across all the different functions, payments, data, connectivity, a little bit our brand and websites. Everything is growing at this point in time in TrueLayer. We've been among the lucky ones of still hiring through COVID, which I think is very, very lucky of us. So if you're interested of anything that this sounds catches your attention of what you're interested to do, just reach out to us, reach out to me, and we can have a conversation.
Awesome. Okay, cool. I'll tag you in all the relevant pieces as well. So if anyone can drop Luca a DM, LinkedIn message, obviously that's going to be massively appreciated, I'm sure, on their side. From our side, if you can do the usual like, shares, follows, apologies, but this is what we think is really good for the community to be able to share some of the really interesting pieces that companies are doing. It's not often you're able to hear about the great things like Luca and co are doing at TrueLayer. So this is why we've created Engineers, to be able to bring to light some of these projects. So if anyone else is out there that is doing some really great things that maybe don't have the time to blog regularly, or their team don't have the time to be able to blog regularly, especially through COVID, come and talk to us, reach out to us, give us a brief on what you're building. I can help write a podcast structure. We can unite, talk about it together, and we can help get this content out the door. So please share this with all your friends, all your community. It will go a long way. We're putting a lot of time and energy into this. Thank you so much, guys. Luca,
thanks so much.
You're a star. Sorry, you had to listen to that. Luca, you're a star. That was superb. Thank you so much. So thank you. Thanks, everyone.
Thanks a lot.
See you.
Hey guys, thanks for watching this episode. Massively appreciate you listening and checking in with us. If you want to find out more about us and what we're doing, please check us out on social media. What we're trying to do at Engineers is build a community to drive knowledge sharing and experiences. On Twitter, we can be found Engineers.io. It's no underscore. We've also got a website which is engineers.io. These links will all be posted in the description. Any feedback and comments are massively appreciated. We're always looking to improve on where we can. Thanks, guys.